So the second part of this, I want to move on to the Agile fluency model. And this was developed by Diana Larson and James Shaw, who are two people who have been in the Agile community for a good long time. They, about a year ago, they sent around a draft of an essay that they've been working on describing their fluency model, and they sent it out to various people they knew, including me. And I looked at it and I said, this is really, really good. Could I publish this on my site, on martinfowler.com? And they very gladly, for me, decided yes. And so it's through on my site, but it's very much their work. And they took this by looking at various projects that worked in over the years, and saying we can actually look at how that fits together based on what they looked at as four, what they call levels of fluency. They're actually fairly careful not to call this a maturity model, although it kind of is, but the maturity model term has got so messed up, that's why they're trying to avoid that term. At the very beginning is what they call the one-star level teams. Teams that operate with the appropriate management practices that you typically see on Agile projects. So they're typically doing something like iterations or some kind of Kanban-like thing. They're operating with a backlog, they're doing retrospectives to see how they work with each other. This is a relatively common approach that a reasonably well-functioning early-stage Agile team will do. They said it still takes a few months to get to this kind of point. And it gives you the benefit of being able to have that visibility. This is where you're beginning to see adaptive planning coming into place, and hopefully beginning to see that people orientation begin to come into place. But it also, you don't really get things properly working at this level. You get some improvement, some visibility, but you're not really humming at this point. In order to take it beyond, you've got to take those management practices and you've got to introduce technical practices that support them. And this is where you begin to get some of the bigger benefits. But you need these technical practices. And this actually, based on my background, makes a lot of sense, because this is where a lot of the thinking of extreme programming comes in. You can often say to yourself the one-star operating level is kind of like the default Scrum approach. But even the Scrum experts will say you need to bring in technical practices that are part of Scrum in order to make Scrum work. And extreme programming I always like because it always combines the two together. When you actually operate this way, you do get, I think, some of the true benefits of Agile begin to come out. You can really start doing the adaptive planning once you begin to get this kind of operation working. You'll also notice that teams who operate in this mode often have drastically lower defect rates than usually you tend to see. It's a common effect that we see when we're going in with clients who haven't done Agile stuff before, is that we see projects with significantly lower defect rates as a result. But there is a cost to this. A significant amount of investment in improving those technical skills. And a good deal of time that it takes the teams to reach this level of fluency. When you see a team that's operating at this level of fluency, they've usually been working at it for quite a significant bunch of time in order to get there. The key test, by the way, for the team who's operating at this level is this phrase, ships on the market cadence. What that means is that you can ship product whenever the business wants it. The typical test that I like to use is you develop a new feature, you're not planning to put it into production, the business people say, oh, that's really good, could you put it into production? And you say, yep, let me just move over here, hit a few commands in, yep, it's in production now. And if that freaks you out, then you're not operating at this level yet. The teams operating at this level will do that because they have enough trust in their technical practices that they can actually deploy that well. But it takes a bit of time to get there. The most noticeable thing that I think you see in this is that at the one-star level, you're shifting the team's culture to begin to think about business value. In order to get that second star shift, you need to think about skills. And you need really to decide how far you want to go at the beginning. Because if you're not prepared to make that skill shift at the start, it's going to be much, much harder to reach that second star operating point. So you need to decide, do I want to go to 2 stars or not from the beginning? And the 2 stars, I think, is where you get real payback for what you do. The 3rd star is much tougher to reach. And that's why I say they tend to see this only in a very small minority of the teams they come across. And this is really where the team shifts towards actually deciding to not just building what they think needs to be built, but actually deciding what to build in the tool themselves. This is where a lot of the thinking from things such as lean startup begin to come into play. So with this, what you do is you see a shift where in order to get to the 2nd star level, you need to change your team, but in order to get to the 3rd star level, you need to make larger changes to the organisation. And again, this is something that to some extent has to be decided at the beginning. Is this a realistic target? For a lot of teams, it's not realistic to aim at the 3-star level. But the 2-star is worth doing anyway. But it's something important to think about when you're working in an Agile context is, can I make that 3rd star point? It's not a sign of failure if you can't, because a lot of organisations are just not ready. But it is a useful, obvious move to make if you think that the operation is up to it. I'm not going to say much about the 4th star level, primarily because they've seen very little cases of it happening, so it's more of a speculative level of what they think may go next. And I'll leave it to you to take a look at the article if you're interested in that. Now, you were showing me a timing thing. Could you show that to me again? Because your timing thing and my timing thing weren't matched up, so I want to know where we are. You're allowing me 20 more minutes. Okay, I thought I had a bit more than that. So what I'll do is I'll move on to, I'll just do 2 talks rather than 3. So, I shall move on to the next one, which is... So for my second talk, I'm going to talk about why software design is important. I'm someone who has kind of spent, I would say, if I'd sum up my whole life and career, it is about talking about software design, trying to figure out what makes good software design and how to pull it off. And so, if I'm going to do this, I always think that if it's worth doing something, you need to figure out why on earth you're doing it in the first place. And it's triggered a lot by this phrase. How many people have heard something like this in their professional lives? Yeah? Quite a few of you have. A lot of a sense of we need to ditch good design at times in order to make other things work. And the question is, how do we respond to that? Particularly if we're someone who feels that design is important. Well, one way of responding to it, a very common way, is, to my mind, very much summed up by this guy. How many people recognise him? This is Uncle Bob Martin, a great speaker, if you ever get a chance to see him talk. And, you know, the way he would respond to that kind of statement is something like this. Bad software design is a sin! Mutable global state is the work of the devil! And every time you name a variable badly, it will be branded into your flesh as you burn in the fires of hell! The trouble is, I can't really do that Bob Martin preacher shtick very well. But there's also a more fundamental problem, which is, and it's a problem I run into with a good bit with teams. A more common statement I often hear is when a team says to me, yeah, they want us to reduce our design quality and not put so much effort into what we're doing, not put time into refactoring, not put time into keeping the code clean, because they want us to go faster. And we tell them, no, we've got to do a good job, it's our responsibility. And they say, no, we've got to go faster. And the trouble is, when people are pushing back in that way, the sad thing is they've already lost the argument. As soon as you start talking about it's our professional responsibility, we have to write clean code because clean code is a good idea, you've lost the argument. And the reason you've lost the argument is because you're trying to argue with ethics, as you were, or responsibility, versus economics. And the reality is, economics always tends to win over morality. That is a sad reality of much of the commercial world. But I think you can make an argument for good quality design as an economic argument, not as a professional craft argument or something of that kind. What's happening when people are making that argument above, and making that request, is that they're thinking that quality is something that is tradable. And tradable quality, trading off quality for cost, is something that we're very used to doing. You know, when we want to buy a car, we might want a really expensive, nice car, but we can't afford it, and we're not prepared to afford it, so we buy something cheaper. We're trading off quality for cost. We do it with food, we do it with clothing, we do it all the time with things that we come across. We make this trade-off of quality and cost. What do we mean, though, when we're talking about quality of software? Well, it can mean a whole bunch of different things. But some of those things aren't visible. So when we talk about have we got a well-factored code base, good modular design, clear naming, easy to understand code, users and customers of software can't see that. I think about this as a distinction between internal and external quality. External quality, with that, the customers and users of the software can reasonably make trade-offs. They can say, yeah, we don't care so much about the nice user interface, so, I'd rather have a cheaper thing with a worse user interface. And that can be an argument they can sensibly have. But when it comes to the internals of the software, that's something they can't see at all. If a friend of mine is working on some software, let's imagine you've got two bits of software. They both do the same thing, they both have the same functionality. One is really, really nicely designed and is 1,000 RAM. And one is not so well designed on the inside and is only 500 RAM. They both do the same thing. Which are you going to pick? Well, almost everyone will say, yeah, I'll go for the 500 RAM one. It's the one that's, what do I care about whether it's got a nice modular design inside? They both do the same thing. I'm going to pick the one that's cheaper. Now, the way I think about responding to this, why do we care about design? I think of it in terms of thinking of this rather complicated, little convoluted phrase, the design stamina hypothesis. And what I'm doing in this is I'm thinking about how do we look at this kind of plot of functionality versus time. A lot of projects, if you were able to plot this curve, it would look like this, where you're not doing much design, you're not putting attention into design. You move fast early on, you get new stuff done, and then over time, the code base is beginning to get harder and harder to work with. Every time you put in a new feature, you cause bugs over here, and you've got to fix that. You're finding it hard to put things through. How many people have been on projects like this, where you're really slowing down as you're going? Pretty much everyone. But on the other hand, if you put effort into design, if you do the refactoring, you keep the code base clean, you are prepared to put the time in to do that, you can get a different curve. A curve where it says, oh, each time I now need a new feature, I can actually build it really rapidly because I've got all of these pieces, and all I've got to do is fit them together in a slightly different way, do a little bit of shifting of behaviour there, and I'm done. And I get the sense of accelerating as I go on. So I can do things now that I couldn't do before. How many people have been on projects like that? Less people, but a significant amount of people had that effect. That's the difference between the two. It means that, yes, you might be able to buy this piece of software now cheaper, but you won't get an upgrade for a year or two because it's so hard to upgrade the software. While the more expensive software, they're able to give you an upgrade in a couple of months, and then another upgrade, and another upgrade, and their functionality goes faster. So yes, we are, you could argue we're saving people's money by neglecting design in the short term, but we're stealing from them in the long term when we neglect design. Because all we're doing is taking stuff away from them.